right, so let me read what's going on in this question here. Fish enter a lake at a rate modeled by function E. So E of t is the rate in, and there will always be a question like this. They always do a rate in, rate out question. This is like guaranteed to show up. Right, and then fish leave the lake at a rate modeled by L. So L of t is the rate out. And of course, neither of them are very nice functions. They're going to give you really nasty stuff, but this is a calculator allowed question. All right, so both of these are measured in fish per hour, and time starts at midnight. So t equals 0 is midnight. So letter D, is the rate of change of the number of fish in the lake increasing or decreasing at time 5? Explain your answer. All right, so the rate is what they gave us. So it's the rate in minus the rate out. So E of t minus L of t. And so they're asking us, is that E of t minus L of t increasing or decreasing at time, what was it, time 5? Yeah, at time 5, so 5 a.m. So if you want to know if a function is increasing or decreasing, you look at the derivative. Pull this out here. Function is increasing if the derivative is positive, decreasing if the derivative is negative. So we're going to do the derivative of this, like rate prime, if you will. So that's E prime minus L prime, and we're going to plug in 5. So it's E prime of 5 minus L prime of 5. Now this is going to be a nightmare to type in the calculator, so just follow along with me. But if this result comes out positive, then the rate is increasing. If this result comes out negative, then the rate is decreasing. So who remembers how we type a derivative in the calculator? Where am I going to go to type a derivative? Like what menu are we in here? Math, good, perfect. Math, and then good, number 8. And if you forget, it says N derive and F for derivative and integrals. I'm going to do math 8. We're going to do this twice, by the way, because we have 2 functions here. All right, so d dx, I know it says t, but I'm going to type x. All right, and then we want the enter function. So in here, I'm going to put 20 plus 15 sine of pi x over 6. And pi is right here. It's right below clear. It's the exponent key, second exponent. All right, and then it's such that, and we want this at time 5. And I'm going to hit the next arrow to get out of there. All right, so that is E prime of 5. And we want to do minus L prime of 5. So I'm going to do minus, and then do another math 8. Because it's E prime minus L prime. So I did minus, and then I'm doing another math 8. So d dx. And then this function is right here. So 4 plus, sorry, I'm trying to keep this where there's not like a glare. It's like impossible here. Plus 2 to the power 0.1x squared. And then again, at the end, we want such that 5. And so here's moment of truth. Again, if this result is positive, then the rate is increasing. Negative means decreasing. So we get negative 10.722, and you need at least 3 decimal points. And I always truncate, which just means take the first 3 that are there. You can round if you want. It would be 0.723. So that's what we got. And then your answer is a sentence. The rate, because they want you to explain it here, is decreasing at time 5 because E prime of 5 minus L prime of 5 is negative. So this is your answer with your justification there. All right, anything else on question 1 before we go on to question 2? Remember, I cannot do all of them. I am going to post the answers to all of them. But any other of the parts for question 1, or do you guys want to move on to question 2? Okay, I'm not hearing anything there, and I don't want to have dead space in here because I want to go over as much as we can. So here's question 2. Go ahead and type in the chat what you want to go over from question 2. This is another calculator allowed one. All right, part A. And they are pretty much guaranteed to ask you to find a polar region. Like that's gonna show up. Like they're going to ask you that. All right, so let S be the region bounded by the polar graph, this thing. They give you the interval 0 to square root of pi, as shown in the figure above. Find the area of S. So just to review the formula, it's 1/2 integral from alpha to beta, r squared d theta. This will show up on the AP exam. You're going to have to know that. All right. But this one's not too bad because they gave you literally everything that you need. So it's going to be 1/2 integral from 0 to square root of pi. And then this thing squared. And then d theta. And you can even just write r of theta squared in there. You don't have to copy this all out. I just did so that you could see what I'm going to type in the calculator. Because this first one, all you have to do is write that out and then type it in the calculator. And you don't have to be in polar mode. I'm going to just type X. Like this one said T, but I typed X. Same thing. You can put it in polar mode if you want to, but it's not necessary. It's gonna work out either way. All right, so we're going to have 1/2. And then math 9, and it was 0 to square root of pi. And then in here, now you're going to have to start your own parenthesis because the parentheses showing in the calculator right there are like going to be this whole thing. So you need to start your own parenthesis and then type all of this. So 3 square root, again, I know it says theta, but I'm typing X. It's just as long as you have the variable, then you're fine. All right, sine of x squared, close that parenthesis, and then close that parenthesis, squared, and then dx. So typing it is a real bear, right? And then hit enter. It's going to think about it for a second, and then just write it to 3 decimal points. So 3.534. And I'm going to post both my work and the scoring guide. And so they'll tell you what they gave points for, but typically it's a point for setting it up and then a point for the answer. Oh, by the way, hey guys, what mode do you need to be in when you take the AP exam? Good, perfect, radians. And if you go to, ooh, whoops, I hit math. If you go to mode, it's the default one. So unless you've changed it to degrees, then you'll be good. All right, what else from question 2? That was part A. Is there another part from question 2 that you guys would like to look over together? I didn't. We're going to do another break, and so I'll ask it when we come back. All right, C. So C says, there is a line through the origin with a positive slope M that is dividing this leaf here into 2 regions with equal areas. So this line is going through the origin, it's doing something like that. And it's splitting the area into 2 equal areas. So write, but do not solve an equation involving one or more integrals. So there's a couple different ways you can do this. I'm going to show you how I would set it up, but you know, there's a few options that could all be correct. The solution would give the value of M. So what I'm going to do is I'm going to write one integral that gives the first half and then equal that to the second half. The other thing you can do is write the whole thing and then like do half of that. So again, like I said, there's a few ways that you can do this. And we want it to have an M in it with this positive slope M. So these are angles, this alpha and beta, that's why they're written that way, is because they are angles. So we have to convert this m value so that it's an angle. And the way that you convert that is with tangent, which what am I doing here, C? So tangent of theta is y over x, and that kind of comes from like when we do the unit circle. You can think of it as opposite over adjacent, or rise over run, because this is going to be our slope. So tangent of theta equals m, and to get theta by itself, you're going to have to do tangent inverse or arctangent, whichever way you want to write that. But theta is going to be tangent inverse or arctangent of m. And so this is going to be, and I'm going to use this formula right here. I'm going to do the first half and then equals the second half. So it's going to be 1/2 integral from 0 until here. So tangent inverse of m, r of theta, oops, messed up my parentheses there. Let me do a take 2 there. R of theta squared d theta. And again, you can write out the whole equation if you want, but r of theta squared is fine. So that's the first half equals, oh, I need the 1/2 out front. Equals 1/2, and then I'm going to do the second half. So I'm picking up where I left off. So tangent inverse of m, and then it goes to square root of pi. 0 to square root of pi was the interval they gave. We're just like stopping this halfway through. And then again, r of theta squared d theta. And this whole thing constitutes your answer. It said set up but do not solve an integral or an equation involving one or more integrals that would give you m. So you just leave m in there. All right, let's move over to question 3 so I can do a few from that. What would you like from question 3, everybody? Let's do a couple of these ones. All right, we went D. All right, so this is the graph of F. Let's look at what they gave us. All right, so this is the graph of F. Continuous function defined from -6 to 5. We have 2 line segments, a quarter of a circle. That's interesting. Lots of times they give a half circle, a semicircle. This time it's only a quarter of a circle. And then they tell us this, the point 3, 3 minus square root of 5 is somewhere on there. I can't remember which part of this you use that in, but that information does come up in one of the parts here. All right, so let's see what D is. Oh, D is interesting. I remember seeing this question after they released the exam and like both liking and disliking it at the same time. Don't you feel like you're supposed to do L'Hopital's rule? Like they're trying to get you on that? You don't. Its limit is x goes to 1, and literally all you have to do is plug in 1, which is nice, but I know that a lot of my kids probably missed it because they were thinking there was more to it than that. All you have to do is plug in 1. Now, if it comes out to 0 over 0, that's where you would do L'Hopital's rule. But it doesn't, it just works out. All right, 10 to the first is just 10 minus 3 times, all right, now here we do have to actually go to the graph and evaluate this. We need to do f prime of 1. So if we come up here to the graph of f, here's 1. The derivative means the slope. So we need the slope at 1. So hey guys, what is the slope of this line? That's what we're looking for. That's what f prime of 1 would be. So what is the slope of this? Good, perfect, 2. So f prime of 1 would be 2. And then in the denominator, it says f of x. So f of 1, slide this back down again. So f of 1 is just 1. And then minus, and then arctangent of 1. And they will accept this. You don't even have to evaluate the arctangent. You can even just leave it as arctangent of 1. And that's the answer. So I both loved and hated that question. It was nice because that's all you had to do. But I guarantee you, like 100% of my students were like, that's it? That's all we have to do? Yeah, so that's it. If you were going to have to evaluate arctangent of 1, that would be pi over 4. like if you had a multiple choice question where you had to evaluate that, the reason it's pi over 4 is that's where both of these sides are the same. Anything over itself gives you 1. But a free response, you don't have to evaluate it. You don't have to evaluate any of the trig. You can leave stuff as like sine of pi and they'll take it. So, so on free response, you can definitely just leave them all alone. All right, maybe one more from this question. Is there another one from number 3 that you guys want to look at real quick? All right, B. All right, so we're going to evaluate integral from 3 to 5 of all of this. I would break it into 2 separate integrals. And I would also probably put this 2 out front for the first one. So I'm going to break this up and make it 2 integral from 3 to 5 f prime of x dx, and then plus integral from 3 to 5 of just 4 dx. So I broke this into 2 separate integrals. So when you have an integral of a derivative, like integral of f prime, what is that going to give you? Like what happens to the derivative and the integral? What is this result going to be? Yeah, perfect. They cancel. So this is just going to be 2f of x, such that 3 to 5. You can think of it as the antiderivative of f prime is f. I like to think of the derivative and the integral canceling, their inverses. You could think of it as the derivative of this gives you this. Either way, that's what you're going to get there. Plus, antiderivative of 4 is 4x, and then such that 3 to 5. So we're going to do 2f of 5 minus 2f of 3. So let's evaluate f of 5. So if we come up here, f of 5 is 0. And then minus 2 times f of 3. So f of 3, oh, here's where this comes up. Because when you go to 3, that's not on an exact point. It's right here. F of 3 is 3 minus square root of 5. So when you read the problem, you're like, what on earth is this random piece of information doing here? Well, that's where it came up. It says 2f of 5 was 0 minus 2f of 3 was this nonsense. Plus, and then we're going to do the same thing here, upper boundary minus lower boundary. So 4 times 5 is 20, minus 4 times 3 is 12. And you can just stop and leave that all in.